find the distance between 2 points on the coordinate plane, there are two different ways you can solve that. You can either use the distance formula, which is the square root of the difference between the x values squared plus the y values squared. And that is a viable way to solve. Unfortunately, this particular formula is not on your MCAS reference sheet. So some students find that using Pythagoras' theorem is easier. So when you connect, so that length of that line segment, okay, we can find that by drawing a right triangle, just like you would if you were solving for the slope of a line. But Pythagoras' theorem also allows us to find the missing length of a right triangle if we know the two other sides. So the red lines that we drew, we can count that the length of the length from P to R and the length from Q to R, and that will give me my two sides A and B. So Pythagoras' theorem, for it to work, the longest side, or the side opposite the right triangle, the right angle, has to be C for this formula to work. So, and it doesn't matter if you interchange A and B. Okay, so from -2 to 5, it has a length of 7. From R to Q, we go from +2 to 8, and that is 6 units if we were to count. 1, 2, 3, 4, 5, 6. And C squared will always be the length of the segment that you're trying to solve for when you're looking for distance. And then from here, you just have to remember PEMDAS. So we always do exponents before we add. So this is going to be 49 plus 36, because don't forget, 7 squared is the same as 7 times 7, and 6 squared, of course, is 6 times 6. So that's how I got 49 and 36. After we do exponents, we add. So 49 plus 36, which gives us 85, equals C squared. And the very last step of Pythagoras' theorem is always to take the square root, because taking the square root of both sides of the equation is the inverse or opposite of squaring a number. Now from here, we can either put our answer, use our calculator to find this, what the square root of 85 is. So the square root of 85 is 9.2. So that is the length of PQ in decimal form. We could also solve for the square root of 85 in simplest radical form by factoring out our perfect squares, which you can watch as a separate video.